Ever glance up at the clouds and, wonder if we could actually tinker with the weather? It might sound like pure science fiction.
Yeah, it definitely has that feel.
But the reality is we're already doing it. In certain parts of the world, anyway.
That's right.
Welcome to this deep dive. We're plunging into the, fascinating and definitely intriguing world of geoengineering and weather modification.
Yep.
Our goal today is pretty simple. Get a clear picture of what geoengineering really means. Find out about some real-world projects that are actually happening now. And figure out who's footing the bill for all this research.
Exactly. So at its core, geoengineering, it means these significant intentional interventions.
Intentional, okay.
Yeah, in the Earth's climate system. The main goal is really to counteract the effects of climate change.
So, kind of pushing back.
Yeah, think of it like trying to adjust the planet's temperature, like tweaking a giant thermostat.
Okay, let's unpack that. So, tweaking this planetary thermostat, what are the main ways scientists are looking at doing that?
Well, broadly, you've got two main approaches. First is carbon dioxide removal, CDR.
Right. Pulling CO2 out.
Exactly. Methods focused on actually extracting CO2 from the atmosphere. So things like, huge tree planting project.
Reforestation, sure.
Or even high-tech stuff designed to capture CO2 right out of the air.
Okay, that's one type. What's the other?
The second main category is solar radiation management, or SRM.
SRM.
And these techniques, they aim to reflect some of the incoming sunlight back into space.
So cooling things down by blocking some sun.
Basically, yeah. Trying to reduce how much solar energy the Earth absorbs.
Interesting. Okay, so out of those two big categories, CDR and SRM, where are we focusing today?
For this deep dive, we're going to mostly focus on solar radiation management, SRM.
Got it.
And within SRM, there are really two techniques that have gotten the most attention, generated the most buzz, you could say. Stratospheric aerosol injection, SAI, and cloud seeding.
Okay, SAI. That sounds pretty technical. Can you break down what that actually involves?
Sure. So stratospheric aerosol injection, it means releasing very, very fine particles way up high.
How high?
Into the stratosphere, the upper layer of our atmosphere.
Okay, particles in the stratosphere, why?
The goal is to reflect sunlight, bounce it back into space before it warms the Earth.
Is there a natural example of that?
Absolutely. Think about what happens after a huge volcanic eruption. Remember Mount Pinatubo back in '91?
Oh, yeah, definitely. That was massive, a global event.
Precisely. When Pinatubo blew, it shot millions of tons of sulfur dioxide way up into the stratosphere.
Millions of tons. Wow.
And that created this layer that actually cooled the planet measurably by about 0.5 degrees Celsius for over a year.
0.5 degree from one volcano.
Yeah, so SAI is basically trying to mimic that effect, but, in a more controlled, maybe sustained way.
Wow, okay. So nature gave us a proof of concept almost.
In a way, yes.
And what about cloud seeding? That sounds a bit, less dramatic maybe.
It's definitely more localized. Cloud seeding involves putting substances into clouds, usually tiny bits of silver iodide, sometimes salt.
Okay, putting stuff in clouds. To do what?
To encourage more rain or snow to form, basically giving the water vapor something to condense onto.
Like giving it a little nudge.
Kind of, yeah. And what's really striking is this isn't just theory.
Right.
It's actively used right now in over 50 countries around the world.
50 countries?
Yeah.
Seriously. That's way more widespread than I would have guessed.
Yeah, it often surprises people.
Okay, so we've got the basics. Geoengineering, focusing on SAI and cloud seeding. And you're saying there are actual projects happening now.
Mm-hmm.
I think a lot of us probably still think this is all just, computer models and future tech.
That's a really common thought. But nope, we're seeing real applications, real experiments.
Okay, where? Let's dig into that.
Well, maybe let's start with cloud seeding, since it's more established, right?
Sounds good. Where is cloud seeding happening?
Okay, well, the Desert Research Institute, DRI, in Nevada, they run an operational program. It's been going on for a while.
Where in Nevada?
In the Carson-Walker River basins, they use ground-based generators, but also aircraft.
And what are they putting in the clouds? Silver iodide?
Yep, silver iodide mostly. And their long-term studies show something pretty interesting.
What's that?
About a 10% increase, on average, in the annual snowpack because of it.
Wow, 10%. In areas that need water, that could be a really big deal.
It certainly could. And Nevada's not alone. Wyoming has similar programs.
Really?
Yeah, they did a 10-year experiment that showed snowpack increases somewhere between 5 and 15% during winter storms.
5 to 15. Okay, so similar results.
Seems like it. And even down under in Australia. the Snowy Mountains project, they reported a 14% increase in snowfall in their target area.
14%. So it seems like boosting snowpack with cloud seeding is, well, almost becoming standard practice in some places.
In certain mountainous regions where water supply from snowmelt is crucial, yeah, it's definitely being used.
What about for other things, like just making it rain more in dry places?
Well, China has probably the biggest weather modification program in the world.
Oh, really?
Yeah, massive. They use cloud seeding to try and boost rainfall in drier areas, but also, kind of famously, to try and guarantee clear skies for big events like the Olympics.
Clear skies on demand. That's ambitious.
It is. And then you look at places with serious water scarcity, like the UAE, the United Arab Emirates.
Right, very dry region.
They've invested heavily in cloud seeding. Reports say they did over 200 operations in just the first half of 2020.
200. And 6 months.
Yeah, it really shows how urgently they view water security.
Okay, that's a lot of activity trying to influence rain and snow. Now, what about the other one, the stratospheric aerosols? SAI. That seems to generate more debate, maybe more concern. Are those experiments actually happening outside of labs?
They are just beginning to move into the real world, yes. Very small scale so far.
Like what?
Well, back in September 2022, there was a UK project. It was called SATAN.
SATAN, seriously?
Yeah, Stratospheric Aerosol Transport and Nucleation. Bit of an unfortunate acronym, maybe.
You think? What do?
They launched a high-altitude weather balloon, and it released about 400 grams of sulfur dioxide.
Where? Up in the stratosphere.
Exactly, into the stratosphere. Just like we talked about with volcanoes, but obviously a tiny, tiny amount.
400 grams. That sounds minuscule compared to Pinatubo's millions of tons.
Oh, absolutely minuscule. But the significance wasn't the amount.
What was it then?
It was that this project, led by an independent researcher, Andrew Lockley, working with European Astrotech, it might be the first verifiable case of a measured amount of gas being deliberately released up there for geoengineering research.
Ah, so it was more about testing the method of release and tracking.
Exactly. Sort of an engineering test. Can we do this controllably and measure it?
Okay, so a very small step, but maybe an important one for moving from theory towards practice.
That seems to be the idea. And it's not just independent researchers.
Yeah.
The UK government itself is getting more involved. In April 2025, they announced a pretty big program, 50 million.
50 million pounds. For what?
Through their new Advanced Research and Invention Agency, ARIA. It's specifically for funding small-scale outdoor geoengineering experiments, but with rigorous assessment.
Rigorous assessment. Okay. That definitely sounds like a step beyond just computer models.
It does suggest a push towards gaining more practical, real-world understanding.
So with these experiments starting, even small ones, and governments funding more,
Yeah.
is anyone watching? Like, are there systems to even know if someone else is doing this?
That's a really good point. And yes, there's work on that too. It's not just about doing it, but also about detecting it.
Detecting geoengineering.
Yeah.
Like an early warning system.
Pretty much, yeah. The U.S. is actively building a system to try and detect if other countries or maybe even non-state groups start doing geoengineering.
How would they do that?
Well, NOAA, the National Oceanic and Atmospheric Administration, they already do regular high-altitude balloon launches.
Okay.
They go up about 17 miles from places like Alaska, Hawaii, New Zealand, all over.
And what are those balloons doing?
They carry instruments specifically designed to sniff out unusual aerosols in the stratosphere, things that shouldn't normally be there in those concentrations.
Ah, so looking for the chemical fingerprints of something like SAI.
Exactly. Kind of like an atmospheric surveillance network, you could say.
Fascinating. Okay, so we're seeing these projects, experiments starting, detection systems being built. The big question then is, who's paying for all this?
Right. Let's follow the money. It's crucial.
Government seemed like the obvious starting point.
Absolutely. And the UK government, as we mentioned, is becoming a pretty significant backer right now with that 50 million ARIA program.
Yes, and besides that, for outdoor tests, they also have a 10 million Aftachan program through their National Environment Research Council, NERC.
And what's that 10 million for? That's more focused on the computer modeling side, the analysis, trying to understand the potential effects.
So the UK is investing in both the practical experiments and the theoretical understanding.
Seems that way.
What about the U.S. government? Are they funding this too?
They are, yes. It started ramping up a bit more recently. In 2020, Congress started funding NOAA's Earth's Radiation Budget Program.
Earth's radiation budget.
Yeah, it got about $22 million over 3 years, specifically for studying SRM techniques and also for developing those detection systems we just talked about.
Okay, so around $22 million from Congress for NOAA.
Right, and that program is key because it looks at how energy flows in and out of the atmosphere, which is, fundamental to understanding how SRM might work or what it might do.
So there's definite government interest in the U.S., both for research and monitoring.
Yes. And also, the 2022 Appropriations Act actually told the White House Science Office, OSTP, to set up a working group.
A working group? For what?
To coordinate all the federal research on climate interventions, pulling together agencies like NOAA, NASA, the Department of Energy.
Trying to get everyone on the same page.
Kind of, yeah. And it's worth mentioning, the National Academy is a really respected scientific body. They recommended a much bigger U.S. research program.
How much bigger?
They suggested something like $100 to $200 million over 5 years for a comprehensive solar geoengineering research program.
Wow, that's a big jump from the $22 million. Has that happened?
Not yet, no. That level of funding hasn't been fully implemented. It was a recommendation.
Okay. So governments are major players funding research and monitoring. What about other groups, universities?
Oh, definitely. Academic institutions are doing a lot of the basic research. Harvard University is a big one.
Harvard.
Yeah, they launched their own solar geoengineering research program back in 2017. They're seen as a leading center.
And where does Harvard get its funding for that? Is it government money too?
Mostly private, actually. Big foundations like the William and Flora Hewlett Foundation, the Alfred P. Sloan Foundation, and also Bill Gates.
Bill Gates. Okay, so significant philanthropic money going into academic research.
Yes. And it's not just Harvard. There are other key universities involved, too.
Like who?
University of Washington, Cornell, Rutgers, and also the National Center for Atmospheric Research, NCAR. They're all active.
So quite a network of academic brainpower working on this.
Mm-hmm.
What about nonprofits? Are they funding things or maybe pushing for certain policies?
Yes, absolutely. There's an interesting nonprofit called Silver Lining.
Silver Lining, what do they do?
They give out research grants, mostly to universities, and they also advocate for what they term responsible geoengineering research.
And who funds Silver Lining?
Their money comes from places like the Pritzker Innovation Fund, the Moore Foundation, and also individual philanthropists like Chris Sacca and Crystal Sacca.
Okay. And you said they advocate.
Yeah, and interestingly, the founder of Silver Lining, Kelly Wanser, apparently played a pretty key role in convincing Congress to actually fund that NOAA research program we mentioned earlier.
So nonprofits acting as both funders and lobbyists in a way.
You could see it like that, yeah. Pushing for more research to happen.
So it really sounds like the money is coming from this triangle of government, academia powered by philanthropy, and these dedicated nonprofits.
That's a good way to put it. A diverse mix of sources all pushing the field forward in different ways.
Okay, now with all this happening, the research, the early experiments, the funding, what about rules, regulations?
The governance question. That's huge.
Especially for something like SAI that could have global effects, right?
Yeah.
Are there international treaties or national laws?
That is a really critical point, and the short answer is not really. Not yet.
No comprehensive rules.
There isn't a specific comprehensive international agreement just for governing geoengineering.
Okay, what about within countries, like the U.S.?
Well, the U.S. does have the Weather Modification Act of 1976.
All right, you mentioned reporting.
Yeah, it requires reporting of weather modification activities.
Yeah.
But, and this is a big but, it was designed for things like local cloud seeding.
Not for spraying aerosols in the stratosphere globally.
Exactly. It wasn't really built for these potentially huge-scale climate interventions like SAI. It's just not equipped to handle the scope or the potential consequences.
So existing rules don't really fit the new potential scale.
Pretty much. NOAA does collect data under an even older act, the Weather Modification Reporting Act of 1972.
Okay.
And under that, anyone planning weather modification has to tell NOAA 10 days beforehand.
And if they don't?
There can be fines up to $10,000. But again, you see the problem, right? A $10,000 fine for potentially altering the global climate.
Yeah. It seems a bit out of scale.
It really highlights the gap in governance for these larger scale ideas.
Okay, so let's just quickly recap where we are. We've defined geoengineering, focusing on cloud seeding and SAI. We've looked at some actual real-world projects, cloud seeding happening in many countries, those very early SAI experiments starting up. And we've traced The money governments like the UK and US stepping up funding, universities doing research backed by foundations and donors, and nonprofits pushing things along.
That covers it pretty well. It's really quite something how quickly this is moving from just theory into actual experiments and dedicated funding.
It really does feel like we're on the cusp of, well, something potentially significant in how we interact with the planet's climate. And that, of course, leads straight into the next big set of questions, doesn't it?
Absolutely. The what-if question.
Right. What are the potential consequences if we actually deploy these things on a larger scale? What could they do to the climate?
Could they be a vital tool against climate change? Or could they maybe backfire, create whole new problems we haven't even thought of?
Exactly. Benefits versus risks.
That's where the discussion gets really interesting and, frankly, really crucial.
And that's what we'll tackle next time.
That is precisely what we'll be diving into in our next exploration. Unpacking those potential effects, good, bad, and uncertain. It's the vital follow-up.
Okay, so for now, maybe the next time you look up at the sky, just remember that the clouds, maybe even the clear blue above them, well, they might be subject to a bit more human intention than you thought.
Worth keeping in mind.
Keep that curiosity going, and please do join us next time as we dig into the potential impacts of actively tweaking that global thermostat.